Hello everyone, today we will be seeing the definition of convergence of sequences. So the definition goes like this: a sequence Sn is said to converge to a limit or a real number L if for every epsilon greater than 0, if for each epsilon greater than 0. So what is epsilon? A very small positive integer, a very small positive number which is greater than 0. So for each epsilon greater than 0, there should exist a positive integer such that we'll have the condition Sn minus the limit L. The difference of these two should be less than the number we have considered, which is epsilon. For all, here n is natural number. So for all, this is for all n greater or equal to n. So if this is true, then we can write limit n tends to infinity Sn equal to L. If this condition is satisfied, we can write it as limit n tends to infinity Sn will tend to limit L. So here first we will be proving a theorem on sequences, limit of sequences. So here every convergent sequence is bounded. So in order to prove this, we will be considering a sequence. Converges to a limit L. So why we have considered this? Let us check it. We have been given every convergent sequence is bounded. So first we'll consider a convergent sequence, then we'll prove it to be bounded. So since we have considered a sequence Sn converges to a limit L, so we'll be using the definition of convergence of limit. So first of all, what was the definition? For each epsilon greater than 0, there exists m belongs to n, means m is a positive integer such that Sn minus L is should be less than epsilon. So we'll be using the definition. First we'll consider let epsilon greater than 0 be given. So we can consider for epsilon greater than 0, there exists a positive integer m belongs to n such that we can write the definition of convergence of sequence. Sn minus L is greater or equal to epsilon for all n greater or equal to m. So if we remove the modulus, so we have to consider of both the sides. In this side there will be plus epsilon, in this side there will be minus epsilon. So we'll have to make this middle term, we should only be left with Sn. So we will be adding plus L on both sides. It will become L minus E, and here we'll be left with Sn minus L plus L. Similarly, L plus epsilon. So here L minus plus, it gets cancelled out. So we are left with L minus epsilon is less than Hn is less than L plus epsilon. We have got this condition. So we'll be next we'll be considering some values. Let G is equal to minimum of L minus E and capital G as maximum of L plus E, S1, S2, so on up to Sn minus 1. So here, why we have considered this, we will be seeing this, we have considered the lower bound to be minimum of this all values of a sequence. So for G, we will be considering the minimum value of this value, and for capital G, we have to consider the maximum of these values. So here we can see that the minimum value is L minus epsilon and maximum value is L plus epsilon. So we can write this condition as, we can write G in place of L minus epsilon and capital G in place of L plus epsilon. Why we have given this is less than or equal to, since it can also be equal to this value Sn. Hence Sn is bounded. Since what was first, let's look at the definition of bounded sequence. A sequence is said to be bounded if it is both bounded above and below. So here we have got the condition where the sequence is bounded both below and above. So the sequence Sn is said to be bounded. Thank you.